Hi, today we'll talk about the basics of trigonometry. Okay, and trigonometry is essentially the study of circles. Actually, we might have learned it as study of triangles, but probably it makes more sense if we call it as study of circles. Okay, let me give an example. Okay, and let's draw a simple circle first. Okay, and we'll take it from there. So it is just a circle. Okay, and let's make this as the center of the circle. Okay, and let's this is the radius of the circle r. Okay, and let the radius be 1. If the radius is 1, we call it as a unit circle. Okay, it could be like 1 meter, 1 millimeter, 1 kilometer, doesn't matter as long as it is 1 unit. Okay, it's called unit circle. So there are a few things which we should remember when it comes to circle. Okay, the one is the circumference of the circle. Okay, just having a formula of 2 pi r, and the diameter of the circle is nothing but the length of the car. Okay, so it is like 2r, 2r plus r is 2r. Now in our circle the radius is 1, so it becomes 2 pi divided by 2 because radius is 1. Now these two gets cancelled, so it becomes pi. So the the value pi is nothing but the ratio between the circumference of the circle and the diameter. Okay, circumference of the circle and the diameter. This ratio remains true irrespective of the size of the circle. So that is how we have this constant pi, which is equal to again 3.14. Okay. Now what is pi and what is 3.14? Okay, there are two ways in which you can measure how far we have moved around the circumference of the circle. The one is using the degrees. Okay, let's say this is the degree theta. We can say we have moved theta degrees away from this point to this point. Then you can say we have moved theta degrees away from this point. Then you can say you have moved theta degrees from this point to here. So if you measure it as in degrees, we call it as 0 degree. Okay, and if you come here it is 90 degree. Okay, and if you come here it is 180 degree, and if you come here it is 270 degree, and the full circle it becomes 360 degree. This is one way of measuring the way we traverse around the circle. Okay. The other way is using pi. Okay, pi is nothing but radiant. This is basically the amount of distance you have walked around the circle from here to here. So let's say it starts with 0 and we measure it in radiant. And if you go around 90 degree, it is nothing but pi by 2. Okay. If you go around 180 degree, it is pi. If you go around like 3/4 of the circle, it is like 3 pi by 2, and here it becomes again 2 pi. So the entire circumference of the circle you can specify it in two ways, either in degrees or in radians. So if you see here, if you call it as 3.14, probably it is like 1 radian, 2 radian, 3 radian, and a little bit of additional radian. So that's why it is 3.14, and this ratio is always constant between circumference of the circle and the diameter. Hence, we have this constant pi. Just like we have square root of 2 sorry, not the square root of 2. That's a different example. Just like you have a constant like e. Okay, e is nothing but 2.178 or something. So just like we have e as a constant, we have pi as a constant, which is what defines this number. So now, as I mentioned, why circles are very important and why trigonometry is around dealing around circles is when you start rotating around the circle, okay, and this point, let's say this is a vector, okay, it always makes some projection into the x-axis and makes some projection into the y-axis. Let's say this is y and this is x. Okay, let's say we have two axes and this vector rotates around it. So the projection this vector makes on this x-axis, let's say this radius is 1, okay, and it makes a projection on this. This is what we call it as cos theta. Okay, the projection of this vector on the point onto the x-axis is called the cos theta. The projection of this point onto this y-axis is called sin theta. Okay. Now this defines cos and sin. What is cos? So now what this projection becomes, this becomes a triangle. Okay, so this is where we study triangles and theta. When I say cos theta, we talk about like this becomes 90 degree. Okay, this becomes hypotenuse, and this becomes adjacent side. Okay, and this becomes opposite side. The cos theta is like adjacent side by hypotenuse, which becomes r by hypotenuse. Okay, so that is how the relationship between a circle then happens with the triangle. Okay, the projection of this point into the x-axis. Now, since it's a unit circle, okay, let's say this vector is starting here, then the point, I mean the amount of information it has on the x-axis becomes 1. That is radius of the circle. So that is why the cos 0 is 1. Okay, cos 0 is 1. And if this angle theta moves up to 90 degree, it doesn't make any projection into the x-axis. That's why cos 90 is 0. Okay, cos 90 degree is 0. So if you talk about this in degrees, okay, cos 0 becomes 1. Okay, let me put one more example here just to specify it, the x and y directions. This is x, this is y, and this is the vector. The same vector here. Okay, let's call it as v. Okay, this vector represented as with an arrow, and the angle, the position it makes on the x-axis is called cos theta. The position it makes on the y-axis is called sin theta. Okay, and if x is equal to let's say this is 0 and this is 1, this projection exactly, I mean, falls onto the x-axis. So the cos 0 becomes 1. Okay, that's why cos 0 is 1. We get the length of this becomes 1. And similarly, when you rotate it, this is theta. So when you rotate from 0 to 90, cos 90 becomes 0. And if you consider these two as vectors, like these two vectors becomes perpendicular to each other, and hence cos 90 talks about if the cos 90 talks about this zero similarity between two vectors, both are like completely orthogonal to each other, and that they don't share any similar direction. So when you say similar direction, like these two vectors share some portion of the similar direction. That's why these two are kind of very, even though they're not exactly the same, probably they're sharing something similar direction. So if two flights are flying towards this point B and C, they start here, and to some extent they probably share some similarity between the same direction, and they diverge and go like this. If the same flight goes this way, which means that starting from this point 0, both flights take exactly perpendicular direction, they don't share anything similar to it. So let's say one more flight flies this way, they start here and they go to destination, let's say Y. They start from here and they fly exactly opposite to each other. So they don't share any direction with each other. So this becomes like, like cos becomes 1, here it becomes -1. So if you take full round of a circle and come here, okay, this is like 0 for cos theta, and this is like cos 90 becomes becomes cos 0 is 1, cos 90 is 0, and cos 180 becomes -1. It's like completely opposite directions. This is how we use cos theta or cosine similarity to identify closeness of two different vectors, and the direction in which they travel, sharing some of the directions. Okay, that's how this is all related, and it's very important when you try to talk about similarity of two things in to machine learning or data science. Say similarity of a king and a queen. Okay, they share some royalty between them, so that they probably have some very close vectors like this, and the similarity is a little bit higher because king and a queen. Let's say we are talking about a king and a lion. Probably there is a movie called Lion King. So probably there is some similarity between the lion and the king. Okay, and I mean it is not due to some physical features of between lion and the king, but because of some relationship between, like a king of a jungle is called lion and the king of the country is called the king, and they share some similarities, and both vectors might point some similarities with each